go, guys. All right. Stick to it here. Oh, I see. Nice. Okay. So 240 degrees. How do I set that up to convert it to radians? What do I put on the bottom here? Yeah, because I want the degrees to die. So on the top's got to go how many radians? 5. Cool. And then if you reduce this, what do you get? Hello.
4 pi 3.
Say again. 4 pi over 3. Is that cool? Shaboo. All right. Not too bad. This was a bit trollish, I'll admit, but it's on a practice thing, so I don't care. It's not for points. No degree symbol. So what is this? Radians. So I got 30 radians. So now I want to make it degrees. Of course, what do I want to get rid of? Radians. So what goes on the bottom now?
Pi radians.
Pi of these is 180 of those. So you just throw out your own calculator, get some funky thing, right? I don't know. I didn't put it in the calculator. What do you guys get? Anybody do that? Let's see. 1600 and something.
1718.
I'm cool with that. 1718, roughly. Blah blah blah. Degrees, right? And real quick. All right. Why does that make sense? How many radians in a full rotation? How many radians in a full rotation? 2 pi. That's only 6.28. Twice pi is roughly 6. Are you guys with me? So it's just a little over 6 radians to go how many degrees? How many degrees is this? How many degrees is this? How many degrees in a full rotation? How many degrees in a circle? 360, right? So it's a little over 6 radians is the same thing as 360 degrees. So 30 freaking radians, it's going to be a lot of freaking degrees. So that answer makes sense. 30 radians is insane. Well, it's not too insane. It's like 5 turns, roughly. So 30 radians is kind of a big number because it's just 6.28 to go 1 rotation, right? I don't know, just trying to show you how the answer is okay, it makes sense. Why is C easy? If you could just read it. That's tiny as hell, Jeff, jeez. Why is this easy? What can you do? Yeah, pi is 180 degrees. So what do you get? This goes to 30, so you get negative 150. How's that so far? Is that all right? That's beautiful. Why was these radians were hard? Because I didn't have a pi just to replace with 180. These radians were easy because pi is 180. Great. Yes?
Is it also correct if we convert to 10 degrees?
That's fine.
Okay.
Yeah. If I go back 150, this is the same thing as going forward to 10. I'm okay either way. So you could do the same thing on part D. Or I could just do this. How do I convert that into radians? What goes in the bottom?
180.
180. Because you want degrees to die. So pi rads. And then you just reduce this, right? So that'll be, let's see. 9 goes into both of them. That'd be negative 6 over 20, which then would be negative 3/10. Is that right? I don't know. Looks about right. Or you could change 54 degrees into negative 54 into 306, and then change that into radians. I don't know why you would want to do that, but you could. Is that all right? No? Okay, okay. Did anybody do that? Did anybody change negative 54 into? Okay, beautiful. I wouldn't do that in the car. There's no reason to. Okay. So number 2, I ask you for arc length. So you can write that formula down. So what do I need to know? I need to know the radius. Well, that's nice, because I just told you it's 8 meters, right? And you need to know the angle, and like we talked about, I'm going to make this really clear today, what I mean by this, but when theta is not inside of a trig function, it definitely has to be radians. If it is inside, it could be whatever the shit, whatever way to measure an angle you want. So we'll do more of that today, but this is out in the wild, it's got to be radians, and I gave you 60 degrees. Does anyone start to think in radians, what's 60 degrees in radians? Pi over 3, because 180 divided by 3 would be 60. So 60 degrees is pi over 3 radians. Now see, I'm being really nice to myself. I'm identifying the values for each letter. So now when I go to use an equation, I just throw those things in the right place. So the first part of this is just going to be r times theta. So I get 8 pi over 3 meters. And of course, you can make that into a decimal. It's going to be roughly, I don't know, 7.56, so roughly, oh, Jeff, 0.56, so, I don't know, what is it? What is it? 8.38. 8.38, okay. Okay. So either on the test I might specify to leave it as a decimal, or I might not, but normally, as a human, we're going to say it's 8.38 meters. We're not going to say it's 8/3 of a pi. How far did you walk today? 8/3 of a pi. What? Okay. So what about the area formula for the second piece? That's the 1/2 r squared theta. Now I know what r and theta are. 1/2 8 squared times pi over 3. Right now I know what the things are. Just got to throw them in. 8 squared is 64 divided by 2 is 32, so I get 32 pi over 3. What's the units? 33.51. No, what's the units?
Oh, meters.
Square meters, and then if you want to make that into a decimal, sorry, but
Oh, yeah, 33.51.
33.5 something? Is that what you said? I don't know. I'm just crowdsourcing. Okay. So I would take either one of those, though technically you should say this more than likely, since most of us in here are humans. I don't know, some of you guys might be from a different planet. I wouldn't know. Okay. I might be from a different planet, shit. But most humans would say 33.5 square meters. Okay. How are we doing so far? Those weren't terrible. You just had to remember angle has to be in radians. So when in doubt, make it radians, right? Not too bad. So those first couple were just directly using conversions, directly using formulas. All right, number 3, I'm going to give you 2 ways to do number 3. I'm going to give you kind of a long way to do number 3. And then I'm going to try to show you a short way to do number 3. All right. I'm going to really take time to set this up. I need some room. Okay. So let's identify everything we know. So somebody help me out. What is the radius? 14 inches. What's the time? 30 minutes. So do you see what I'm doing right now? I'm just collecting all the shit they threw at me, and I'm identifying what variable it is. Because I know I'm going to want to use several formulas. So I got to know what the hell to put in there. What else did they tell me?
Linear velocity?
Good. Linear velocity is 5,000 feet per minute. So do you see a problem already? Do the times match? Do the times match? Minutes, minutes, yes. Do the lengths match? No, shit. So, do you want to make 5,000 into inches, 5,000 feet, or do you want to make 14 inches into feet? It really is up to you. You just need them to be the same. What did you guys do that? Did you guys get to that point where you realized, so which way did you go?
5,000 inches.
So you made 5,000 feet into inches, but you guys made inches into feet. All right, so I'm gonna do inches into feet, but it would work the same way with the other way. So how many feet is 14 inches? No, it's not 1 foot. 12 inches is 1 foot. Uh-oh, shit. Yeah, so it's 14 divided by 12, right? So I would just use 7/6 feet. Right? 24 inches is how many feet? 24 inches is how many feet? 2 feet. Why? Because 24 divided by 12 is 2. So what's 14 inches? 14 divided by 12 is 7/6. Now, if you use the decimal, that's okay, but you actually estimated, you rounded, so your answer's not going to be quite right, but it would be fine. Okay, so we scramble into the back. All right, that's all they tell me, right? And what do they ask me for? What do they ask me for?
How many times of this goes?
Yeah. How many times does it rotate, right? How many times does it revolution? So they asked me for the revolutions. All right, what is revolutions directly related to? If I went 1 revolution, can you tell me anything about anything? 1 revolution. What did I go through? If I go through 1 revolution, what's another way to identify what I went through? Say again?
360 degrees.
360 degrees. I love it. What's another way to say that same thing? 2 pi radians, right? So if I knew, just stay with me, every revolution is 2 pi radians, right? We know that. We've talked about that. We're cool with it, right? So if I do all the work and I find out that the tire went through 8 pi radians, how many revolutions did it make? 4. Yeah, every revolution is 2 pi. So what would 2 revolutions be? 4 pi. So what would 3 revolutions? 6 pi. So what would 4 revolutions be? 8 pi. So real quick, if I knew how many radians I go through, I divide by 2 pi to see how many revolutions it went through. Because how many radians does it take to go through 1 revolution? 2 pi. So if I divide by 2 pi, I see how many of those I did. So now I know the whole point of this is for me to try to figure out theta and rads. If I can get there, I can just divide by 2 pi. So we got a lot of shit, right? This problem is not easy, right? So don't feel bad if you had a lot of trouble with this problem. So I'm doing this the long way first, but then I'm going to show you short way and see if you guys kind of understand how it works. Okay, here we go. So what the hell can I do here? I'm trying to get theta. So what formulas do I have at my disposal? I've got these guys, right? So what do I have up there that's related to theta somehow?
Arc length and angular speed.
Yeah, arc length I don't really know, right? But angular speed and linear speed sort of indirectly are related to theta, right? Okay, I like it. So real quick. If I knew this guy, could I figure out the angle? Because don't I also know time? Do you guys see that? I really want you to understand what I'm saying. And again, how am I attacking this problem? Because I know this is what I need. If I get this, I can divide by 2 pi and get this. So I'm just trying to get this thing. And I've got these things. Okay, so omega is related to theta. And how do I figure out omega? Can't I use this guy? So if I use this, can I figure out what little curvy W is? What's V? 5,000. And what's R? 7/6. So can't I figure out what omega is? And again, if you use a decimal, it's okay, but your answer is going to be off by a little bit. So how do I solve? I would just multiply by 6/7, right? If I multiply by 6/7. So I get 3, 0, 6 times 5, 0, 0, 0 over 7. That's omega. Oh man, you guys love this problem. So I went from, ooh, make this into, holy shit. But again, number 3 is a detailed problem. It's got a lot of steps to it. Okay. Why did I figure out omega? Because I can immediately figure out, and now can I figure out theta? Can I figure out theta? What do I have? 2 things I know that will get me theta. Which equation would get me theta directly based on what I know now? Well, what equations is omega involved in? Because we just figured out omega, so now what opens up to me? This guy I already used. This guy. What would theta be? If I solve this for theta, what would it do? Okay. So I know that omega is theta over t. So isn't theta equal to WT or omega t? Okay. So what's theta then? It's going to be omega times time. Holy shit. Theta would then be, am I still on the screen? No. I need to zoom out a little bit. Theta is, so there's my stuff, right? Theta is omega times time. Theta is 30,000, that's omega, right? That's omega. Time is 30. So now I get 9, 0, 0, 0, 0, 0. Yeah! And what did we say earlier? And real quick, this is in radians. It is because I used all real measurements. So it comes out in radians because radians is a real measure. And what did we say earlier? If we just knew the angle in radians. This is the, and by the way, what is this? This is the total angle it travels through. So every time it turns, it goes through 2 pi radians. So we went far enough to go through 900,000 radians. So how do I figure out how many revolutions that is? Divide this by 2 pi. Holy Jesus, Jeff. What kind of problem is this, Jeff? So 900,000 divided by 7, divided by 2, divided by pi. You got to be really careful how you put it in your calculator. You want to divide by everything. And you should end up with, oh God, where is it, Jeff? 20462 .778, whatever. 778, that's fine. So about 28,000 revolutions. Yes?
If not specified on the test, does an answer like this require decimals? Because you can technically go decimals.
If I don't say, you technically don't have to put it to decimals, but you should, because it's an actual word problem, it's a physical problem. If somebody said, how many revolutions your tire do, and you give me some blah, 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 pi, I'm like, what? No, how many times did it turn, right? I want a number.
I rounded to the nearest whole number.
Oh, you're fine. Yeah. If I don't, I should say what to round to. Yeah. Okay. All right, that's everybody's favorite. Let me give you a different way to do this. You ready? I'm going to give you a much better way to do this, which requires you to understand some ideas. Which requires me to have a piece of paper, which I never have. There we go. All right. If I had pretend like that's a circle. If I knew this guy's circumference, let's say, is 10 meters. If I let it roll once, so I'm going to let it roll, so this is going to travel all the way around and come back to here. Is that cool? If I let it roll once, let's say there's a nail right here in your tire. If I let it roll once, won't the nail come back to here? that cool? So in the middle, the nail is like here. So I let it roll once. How far did I go? If I let a wheel rotate once, how far did it actually move? So I know the circumference is 10 meters. Man, it's a big ass thing. It's a giant monster truck, or it's the thing they use to move the space shuttle. Wow. Right. 10 meters is kind of big. You could do this. I know you can do this. Say again? Nope. That is the angle it went through. I want to know how far. If I start my car up and I go forward until my wheel makes one rotation, how far did I move forward? What's say?
10 meters.
10 freaking meters, yes? 10 meters. Do you guys, does anyone see that? If I let this roll, didn't I go through a circumference worth? If the circle turns, didn't it go through a whole circumference worth of distance? Imagine if I had it sitting here, and as it rolls forward, it breaks and kind of lays out. So it's broken now. How? And so it's like it's stuck here, and the rest of it just lays out. Wouldn't this be 10 meters? I don't know if you guys see what I'm saying. So if I had anything, something, I get nothing here. Okay. No, I don't have that with me. Shoot. Dang it. All right. All right. Circle. Right? Let it rotate. Right? Circle. But let it rotate is the same thing as just letting it uncurl. How long is this? Is the circumference of the circle, correct? So if I let it roll until it comes back to the same point, it's gone through a circumference worth of length. Okay, so what the hell am I saying? If I knew the circumference of my circle, and I know the distance I've gone, I could divide the two to see how many rotations it did. So look at this problem. Do I know the circumference of my circle, of my wheel? Yeah, circumference would be pi times diameter, so it's 28. Well, let's make inches into feet like we did earlier. Is that cool? So this would actually be 28 divided by 12, which is 7/3. So the diameter is 7/3 feet. So the circumference would be 7 pi over 3. How far did the car go? This is a very simple question. How fast is the car going? 5,000 feet per minute. And how long did it travel for? 30 minutes. So how far does it go?
15,000.
Yeah, 15, 0, 0, 0, 0, 0, 0, 0, 0. So if I take how far the car went and I divide by the circumference, let's see what we get. Just to help you out a little bit. So you can put it in the calculator correctly. Well, I don't know. All right, let's put this in here. 150,000 divided by 7 times pi divided by 3. Isn't that the same answer we got earlier? Yes? And actually, again, do you have to do it that second way? Well, the fact that I said that second way means no, you don't, because there was a first way to do it, right? So you can do it either way. So if I know how far I go, and I know the circumference, I can see how many circumferences fit in how far I went. That would tell me how many times it rotated, right? So my circumference is 10 meters, and I go 20 meters. how many times did the circle rotate? The circumference is 10 meters, and I go 20. So one rotation would be 10 meters. I went 20 meters. So how many times did it rotate? 2 times. You divided how far I went by the circumference of the circle. If you don't understand that second way, it's not the end of the world. You've got the first way, which is beautifully mathematical. Bunch of equations. Second way is preferable because it's quick, but you have to understand the idea. So what I like to say is the more you know, the less you have to do. All right. And then number 4 is nice and quick, especially if you look on the back. But does anyone remember the 6 trig functions? What even are they? Sine, cosine, tangent,
cosecant,
good, cosecant,
secant,
secant, cotangent. So if I have a triangle, this will be y, this will be x, this will be, you can either say h or r. What will the sine of theta be? What's it defined to be? Yeah, it's the y side over the hypotenuse. So it's the fractional part of the hypotenuse that lies in the y direction. What's cosine? The fractional part of the hypotenuse that lies in the x direction. And what's tangent? Y over x. Notice that tangent is sine divided by cosine. If you divide this by this, don't the h's cancel? So you get y over x. So what's cosecant theta? Why is it easy now that I got this staring at me? Because cosecant is how related to sine. Second? Flip? Yeah, it's just a reciprocal, right? So what's cosecant? H over y. What's secant? H over x. And what's cotangent? X over y. Kabam. And if you would have turned this over, you would see this. Now notice here I'm saying r instead of h, but that's kind of like what that is. It's the hypotenuse. I'm sorry. It's the radius of the circle. So when you see r here, it's the same thing as h. So go ahead and try these out. Get back in your little groups and try to do each of these. So for each one, I want to know all 6 trig values. I want to know what the sine of A is. What's kind of wrong with this one? Well, that's okay, because you can get that with Pythagorean theorem, but where's the angle? It's up here, so I actually need to look at it like this. I need the angle to be in the base. Now, if you've learned SOHCAHTOA, I know, I don't care. SOHCAHTOA will not help you beyond a little bit. If you learn sine likes y, cosine likes x, you'll be able to take it much further. If you know SOHCAHTOA, you could use it, that's fine. Okay. So go ahead and try these out. So the very first thing you have to do, of course, is figure out the missing sides, right? So I'll give you that little hint.